this video, let us learn about volumes in Docker. A Docker volume is a mechanism for persisting data generated and used by Docker containers. Unlike the container's internal file system, which is ephemeral and lost when the container is removed, volumes store data independently of the container's lifecycle, making them ideal for maintaining stateful data such as databases, logs, or application state. Here are some of the reasons why we use volumes. Number one, persistence. Data in a volume remains even if the container is permanently removed. Number two, sharing data. Volumes can be shared between multiple computers. Number three, isolation. Keeps the data separate from containers layers. And number four, performance. Volumes are managed by Docker engine and typically faster than the bind mounts. Docker offers three types of storage. Number one, volumes. These are stored in Docker managed paths. For example, in Linux, /var/lib/docker/volumes. Number two, bind mounts. Host file system path, which is mounted directly onto the container's file system. And then you have the third one, temp fs mounts, stored in the memory only of the host operating system, disappears on the container's stop. Now let's take a look at how volumes are used in real life. I'm switching to a command prompt, and you can start by typing docker volume ls. This is the command that shows what are the volumes that you have currently on your computer. And as you can see that I don't have any volumes. Now, even before understanding what is a volume, so let's go and try to create an instance of a BusyBox, create a file over there, and delete the container and recreate the container to see if the file exists. To start with, I'm simply going to say docker run BusyBox, and I'm going to type the command sh to override the default command. But in order for this to work, you need to be in the interactive terminal. So I'm going to go add here -it, press enter. And as you can see that I have a new Docker container and I'm already inside the file system of that container. And just to check, I'm going to open a new tab and then I'll say docker ps, and you'll see that there is one running container. So I go back over here. I'm going to create a directory. So I'll say mkdir-p/app/data, and then I'll cd into that. And then I'm going to create a simple text file. So I'll say cat greater than sample.txt, and I want this to be saved when I type eof. And I'll just type here, this is a sample file created inside the file system of a BusyBox container. And then I'm going to type eof to create the file. So as you can see that the file exists, and I also have the content like this. Now I come out of this. Now the container is stopped. So if I type docker ps, I don't see that. Docker ps-a, I do have, but it's been exited. So now if I want, I can start this back. So by typing docker start and then use -it. I don't think so I can use an IT over here, but I can say the ID of this. So I'm going to copy this, paste, press enter. You can see that docker ps shows that it is up and running. I can try attaching the current terminal using the docker attach command, or I can simply say docker exec -it, the container ID or the container name, and then I'll type here ls -l/app/data. And there you go, my file still exists even after the container has stopped. However, if I go and remove the container altogether by typing docker rm and then paste the ID, it says it is running. So I may have to forcefully remove that by typing -f. And now the container is permanently gone. So I'm going to say docker ps-a. I don't have any containers. Now, if I recreate the container, obviously the ID will be different. So, but I'm going to just go here and say docker run it busybox sh. Since this is going to be a new container, this has a brand new file system and it doesn't have the /app/data/sample.txt. So if I type here ls-l, you can see that I don't have app as my folder at all. So we have lost the actual file because the file was completely inside the file system of the Docker container, and the Docker container is now no longer in my computer. Now, to avoid this now, what we can do is we can say, hey, certain of the files, let it be inside the container's file system, but some of the files that are related to our application should be in our host operating system. So even if I remove the container permanently and recreate a new container, I can associate my data files with the new container. You can think of this as a pen drive that is attached to your laptop. So you can take certain kinds of data backup in the pen drive. And even if you change the laptop completely, your data is safe in the pen drive. Even if the laptop is completely physically damaged, your application data is safe in the pen drive. And that is what actually a volume is all about. To understand this, let's go and use a volume this time. If you simply type the command docker volume and press enter, since the command was incomplete, so I get the usage help. And it says that these are the commands that are associated with the docker volume command. So creates a volume. Although we don't need to use this command, we can simply create a volume in advance. However, whenever you're trying to create a volume using the docker run command, it will be automatically created. Docker volume ls to get the list of all volumes that you currently have. And then you have the docker volume rm and prune. Rm removes one by one, whereas prune removes all unused local volumes. If the volume is not associated with any containers, then they will be completely removed. Let us go and use a volume. And we saw that there are three types of volumes. One is actually called as a named volume. The second one is the bind mount, and the third is the temp fs. We're going to have a look into the bind volumes to start with, and then we will understand why we prefer to use the named volumes. So let's take the same example. So I'm going to go back to the previous commands, but this time I want to associate a volume. Now, right now I am in my C:users Vinod folder. So first, let me switch to my desktop and I'm going to create a folder, let's say mkdir, and then I create a volume examples as a folder, cd volume examples. And now here I'm going to type the command docker run -it followed by -v, a volume name. And then I'm going to go give here dot slash, meaning I'm giving a location of the current folder. I'll just call it as app/data colon. I'll type here /app/data. And then I'm going to go and start the container by typing the name of the image, which is busybox. And then I type sh. That's the override command. I don't have to give because -it runs the default command by BusyBox, which is sh. So I don't need to give this. So if I press enter, since I'm on Windows, I may have to use the other slash here. Let's give it a try and see what happens. And there you go. So on Windows, we have to ensure that the slash here is according to the Windows specifications. What we did here is we associated the containers file system directory called /app/data, which is supposed to be here, to my Windows, which is the host operating system's current folder, that is on my desktop volume examples folder, a folder called app data or app/data. We we associated with that. And if you type here ls and note that I'm already in the root, I should see an app, ls app, and you can see that I have data. I don't have any files in that app/data because it just got created. However, if I come to another PowerShell window here or a command prompt window, and then I get into my work directory, which is desktop, and there we have the volume examples. If I type here dir, you should see that there is an app folder and then cd app or dir app. There's a data dir app/data, and you can see that there's no files over there. However, if I open a notepad or any editor and create a file here on my Windows in this particular directory, that should be created here and vice versa. So if I create a file here, that file should be reflected here as well. So let's start from Windows. So I'm going to open the current folder in Visual Studio Code. And as you can see that I am under app/data, and I will create a new file under data by right clicking on that and say new file. I'm going to call this as sample.txt. Type in some text here. This is a sample file created by Vinod inside the Windows operating system file system. And I'm just going to go close this and come back here into my BusyBox container and use the same command ls-l app/data, and you can see that there is a file sample.txt. I can type here cat app/data/sample.txt, and you can see I do have the same thing. So I'm going to add some other content into that. Let's say vi sample app/data/sample.txt and press enter, and then come to the end of it, press enter. This line was added using the Vim editor on BusyBox container. Let's save this and exit. Go back to the Windows. I again type here type app/data/sample.txt, and you can see that we have that line as well. So here the volume is completely managed by the user, that is me. So if I go and delete this particular file, the current volume here also get affected. Now, also if you type docker volume ls, you can see that I don't have any volumes maintained by Docker. So this is useful in some scenarios. For example, if you are developing a web application and you want to see the result of your web application directly on the container's runtime, like for example, an Nginx web server, and you want to constantly edit your files, in that case, the containers file system, which is maintained by Nginx with all the HTML content, you can directly edit that in your host operating system tools like VS Code. So let's give an example on the same. Docker run dash D to run this in the background, dash P to associate the ports. Let's use the Windows port of 8080 to Nginx port 80. And then we'll also give a volume. This time I'll say dash V. In my current working directory, I'll call it as my website. It's going to be a new directory now. But that is going to be mapped to slash user slash share slash nginx slash html. And that's the location where nginx is supposed to keep the files. So I'm going to run this container using the image nginx latest. I'm going to press enter. Hopefully it should give me the ID of the new container. And let's just verify that it is running by typing docker logs -f and type the container's initial few letters of the ID. So, and that's going to get the logs, which means it is running successfully. I'm going to open a new browser window and visit http localhost colon 8080 and press enter. And there you go. Let's go and check in the other window or tab. Let's exit out of this. And we see that there is my website as the content. Let's get into that, my website. And if I type here dir, I don't see any file, but let's visit this in Visual Studio Code and add an HTML content over there. Click on the yes, I trust the authors. Close this. Let's add a new file here. Should be index.html in lowercase. Let's add a basic HTML content and let's say my awesome website. And we'll also type h1. I type here my awesome website. Add a HR and let's say add a paragraph created by Vinod. So saved. Let's minimize this and open the browser which gave an error earlier, and let's do a refresh. And there you go. My HTML file that I created in my Windows environment is reflected on the Nginx container. And that is because if I get into the file system of the Nginx, let's go and type docker ps, and this is the one that is running right now. So I'm going to say docker exec -it and then the name of this container or the ID. And then I type here sh so that I can create a shell directly into that and look at the location. So let's look at where am I right now. I'm in the root. So I'll say cd /user share nginx /html. And then if I type here ls-l and you see the index HTML, I'll say vi index HTML and but let's say cat index.html and I should be able to see the content that I created there directly. So if I go back to the Visual Studio Code, add some additional content, let's say we add here a paragraph again. We'll say copyright 2025, all rights reserved, and minimize this. If I come back here and then say, hey, show me the content of the same cat index.html, and you should see the new copyright that I've created in Windows environment. So the host operating system exposes the container file system directly. We can edit and work with that. So this is useful in some cases, but not in most of the cases, because the Docker has no idea about this particular volumes. The Docker container has an idea, container has a mapping, but other than that, we don't get any support from Docker if we want it later. So if accidentally or intentionally the file is deleted or this entire folder is deleted, then it becomes a problem. So we have to manage all these things. Instead of this, we can go with the named volumes, which is completely managed by Docker itself. And most cases, that is what we do. For example, I want to maintain a MySQL database, and maybe I would remove the container in the future, and probably in another future, I might want to recreate the container, but I want the data still. So again, you need to be aware of where MySQL keeps the data. So let's create a new MySQL container to understand this. Before that, we're going to say Docker volume ls. You see that previous examples didn't create any volumes at all. And now I'm going to create a new volume by creating a new container. I'll say Docker run -d and then -p also. Let's add that. 3306 is the port number, so I can connect to this via a MySQL workbench, for example. And the server also has the same port number, so 3306. If you want, you can give here something else, 3307, for example. And that's going to be the host operating system's port number. Then importantly, you need to give the volume, so we'll say -v, and then I'm just going to go type here my DB data, something like that. And importantly, it shouldn't start with the slash or dot slash, because this is not a folder or a file system path we are giving. We are just giving a name to this. And then we simply give colon and the containers file system that we want to mount it on. So I'm going to say /var/lib/mysql. Now, this depends on the container you're trying to create. For Nginx, we saw that it was /user share Nginx HTML, and you need to read the documentation of the image to understand what is the volume that we have to mount. And this is the one that given by MySQL documentation, so MySQL image documentation. And then any other additional stuff, like for example, I have to give an environment variable. So that's the MySQL root password. And I'm going to assign welcome 123 exclamation. And then I give the image, which is MySQL, press enter, and hopefully the server got created successfully. Let's follow the logs, Docker logs -f. I forgot the ID of that, so I'll say Docker PS. So the ID is for MySQL, it's this one. So I'm going to copy Docker logs -f ID, press enter. And you can see that somewhere it says that it's ready for connection. I press Control C, and now let's say we want to connect to that and work with that. So I can open the workbench, MySQL workbench here, or alternately, I can execute a client from the container itself. So how do I do that? So we'll say Docker exec -it. I want an interactive terminal, and the ID of that container, which is I just copied earlier. And then I type here MySQL, that's the command that runs the client, -u root -p welcome 123 exclamation. I press enter. So now you should see that I'm in the MySQL client, but I'm actually running the command from inside of this container itself. And I can say show databases, and this will show the default databases. Let's create one. So I'm going to say create database called WinDB. Use WinDB to get inside the DB. Let's say create table called people, ID int or integer, primary key auto underscore increment, name varchar of say 50, not null, and the table is created. Show tables. Select star from people. I don't have anything, so I'm going to add a couple of records. So insert into people. I'll add values of Vinod comma, let's say Sham, and select star from people. And I do have these two records. Let's exit this and also stop the container. So Docker PS, Docker stop, paste the container ID, and that will take a bit of time to stop, but it's still there. So if I type Docker PS-A, you can see that only Nginx is running, but all others have been stopped. I can remove all of them by typing Docker container prune and then say yes, all these stopped containers are gone. So again, I said Docker PS-A, only Nginx and no other containers. However, I still have the data by typing Docker volume ls. I can see there is a volume containing my DB data. So anytime I want to create a new MySQL container, I can always associate this. How do I do that? Very simple. Docker run -dp 3307 or any other port number, preferably 3306. And then the container port is always 3306 here, -v, and then my db data 2/var lib mysql. Incidentally, the volume contains the user's credentials also, so I don't have to create a root password again. And type mysql, which is the image. I press enter. You can still check Docker logs -f and the ID. Let's copy a few letters from the ID and paste, press enter. You can see that it is ready for connections. So no need to give the password because it's part of the volume now. And once again, this time I can actually use MySQL Workbench to connect because I already have the data in the form of the volume. So I'm going to go connect to that. So I'll add a new connection. Let's call it as a WinDB connection, something like that. Localhost 3307, if you remember. So that's the one that MySQL Workbench would connect to. Root, the password is the same thing. Welcome 123 exclamation. Say OK. The default schema, since I already have WinDB as the schema or the database, so I can use that. I click test connection and we get a warning and it says that successfully made the SQL connection. Say OK and say OK. Double click. You should see that we have the table called people, some data here. So this is how you can create and use named volumes, which is the preferred way of doing. So you won't be able to directly edit the files in the volume, but this is the safest one because Docker is the one that maintains this. In fact, if you are going to use the command docker system prune, which is going to remove a lot of things, you can see that it says all stopped containers, all networks not used by any container, all dangling images, unused cache, but the volumes are still going to be safe. So even if you accidentally run this docker system prune command and said yes, your volumes are still safe. The only way to remove a volume is by using the docker volume rm command, which is something that you have to be carefully executing, otherwise you lose the data. In conclusion, Docker volumes are essential for building robust production-ready containerized applications. They provide reliable data persistence, enable data sharing between containers, and offer better performance than alternatives like bind mounts. Here are the key takeaways. Use named volumes for production applications, the one that we just used with MySQL. Implement regular backup strategies. Follow security best practices. Use the right storage type for your use case. Monitor volume usage and performance periodically. Use Docker Compose for complex volume configurations. Remember that proper volume management is very, very crucial for data integrity, application performance, and operational success in containerized environments.